We're going to start off this by telling you a little story. Some of the story is actually true, but it's kind of the history of numbers and how they came about. The first part is that numbers started out as adjectives, like the number 1, the number 2, the number 3, 4, all these numbers that we use every day. They started out long ago being able to describe trees and pigs and cows and horses and rocks and whatever else you wanted to describe, and you could describe everything in nature, so we call them the natural numbers. This double-lined N is their special signature, and these little braces just mean we're talking about all the numbers in that set. So the natural numbers, 1, 2, 3, 4, 5, on up forever. Well, eventually some smart aleck came up with the idea of, well, we can describe what's there. What about being able to describe what's not there? We need a symbol to describe absolutely nothing. As you can imagine, this debate took on many different forms. People are thinking, what? Are you serious? Are we really going to describe what's not there? And eventually the debate was decided by this symbol right here, saying, yep, we now have 0, 1, 2, 3, 4. This is the set of numbers that we can do everything with. And now that we could describe what is there with these numbers and what's not there, we have no elephants eating no carrots on my table right now, we're complete. And we could call them the whole numbers. This is a double-lined W for whole. Well, then the checkbook was invented. And somebody got this letter saying, you wrote out a $5 check, you only had $3 in the bank, you now have negative $2. Wouldn't it be funny to go down to the bank and say, really? Negative $2? Count them out for me. Let me see. I want to see negative $2. Or, have you ever seen negative 7 trees in a field? Anything like that? Of course not. But we know what it means. It means that these numbers, like 3, 2, 1, they're happening in the other direction. So it goes on forever, 1, 2, 3. These are the same numbers we started with, and we've got 0 in there, and now we have all the negatives headed in the other direction. When you get a bank statement saying you have negative $3, it means you owe the bank $3 instead of them owing you. And this set of numbers is called the integers. Here's the symbol. It's a double-lined Z. That actually comes from the German word Zahlen. Zahlen means numbers in German, and that's the international symbol for integers. Now, integers sounds like a scary word, but realize that we don't have any fractions, no decimals, no square roots. Life is really good in the integers if it stays there. But alas, we do have those others. So we have the set of numbers that includes all of these guys plus all of the fractions. So this would include 3/8, negative 5/11, negative 8/2. Notice this guy is negative 4. He's already in the integers. So we include everything that's already there plus all these fractions that we couldn't. Now these guys are called the rational numbers. And I look at that Q and I'm thinking, Q, that's not very rational at all. Well, the word rational means that it comes from a ratio of two numbers. That's where we get fractions. And this symbol Q can stand for quotient. Now, something about these are that when you turn these guys into decimals, let's see what happens. If you turn 3/8 into a decimal, you get 0.375. If you turn 1/2 into a decimal, you get 0.5. You'll notice that these actually stop at some point. And some of fractions will have this happen. The decimal stops at some point. Others, like 5/11, they don't stop. This goes 0.45, 45, and goes on forever with that pattern, much like 1/3 has a pattern that repeats over and over, a certain block of numbers that will carry on forever. And so here's the characteristic. You're either going to stop with a decimal or carry on forever if you are a rational number. Now, there are numbers out there that are irrational, that are not fractional. So we're going to jump down here and show you this is for all the numbers, all the real numbers. This is basically the number line. Every number you can think of. So here's 0, there's 1, 2, 3. So you'll see the natural numbers hit some of them. And then 0, add the whole numbers and you get that many. Now here are the integers, the rest of the integers coming up now. And they go on forever that way. And then when you get to the fractions, you start having this, you start filling in the holes in between here. Like here's 2 1/2 and 2 1/3 and 1 7/9. So there's a great question as to whether or not the fractions filled in everything. Well, it turns out they don't. There's a number right here that you might be familiar with. You've heard of it before. That number starts out 3.1415926 and then keeps going, but it does not ever repeat a block of numbers as a pattern. This is not a fractional number, or what we would call irrational, not a ratio of two integers. And there are some others in here that you could find, but it turns out that it fills in all the rest of the holes, anything that's a fraction, and now we have anything that's not a fraction, so we now have everything on the list. Now we'll write this out in a different graphical way so you can see it a little bit differently. So if we start down here with the natural numbers, so natural, so remember these are what you naturally start doing when you count. 1, 2, 3, 4, 5, carry on forever. And now we take the number 0, and if we add those two together, we get the whole numbers. There's 0 down there, there's the natural numbers right there, and together they make the whole numbers. Now if you take the whole numbers and put together all the negatives of those, so this would be -3, -4, -5, -2, -1, -6, -7. Still no fractions or decimals, but you put those two together and you get the integers. So integers are your friends, no fractions or decimals. So we take all those integers and fill in the holes between them with all the fractions we can find. And we get, these are the rational. So double line Q. Rational. And if we take everything that is a fraction, could be written as a fraction. Now remember, these are decimals that stop or repeat a pattern, and put those together with the irrational numbers. Then we have everything, and the double-lined R means real numbers. Some examples of these might be 0.12, 112, 1112. Notice how this pattern that I've created, certainly it's a pattern, but it doesn't repeat a block of numbers. So this would be an irrational number, whereas this, if I start out with 0.1212, would have to repeat this forever in order to be a rational number. Integers are not fractions or decimals. Fractions here that aren't necessarily simplifiable. Oh, one other irrational numbers, a set of irrational numbers that are going to be very handy. If you take square roots that don't come out nicely, like square root of 2 would be an irrational number. And that'll do it.